Hello everyone, welcome to the second session of the chapter Solvents. Technically this will be numbered as session number 11, but it is the second session. In the previous session we have seen what are the different types of classification of solvents. In this session we are going to study comparative account of water and liquid ammonia as solvents. Okay. So when we compare liquid ammonia and water, let us look at the properties. We have 5 properties named here. The first one is hydrogen bonding. Second one is a liquid range. Third one is a dielectric constant. Fourth one is viscosity. And the last one is self-ionization. Let us look at hydrogen bonding with respect to water. We should recall hydrogen bonding is a bond between electronegative atoms. Okay. And we call it specifically hydrogen bonding when there is hydrogen involved in it. When it is water, you have two lone pair of electrons on oxygen, right? H2O, two lone pair of electrons on oxygen. We know that oxygen is more electronegative than nitrogen. Okay, two lone pair of electrons on oxygen, and it is more electronegative than nitrogen when it comes to water. When you have ammonia, liquid ammonia, NH3, we have only nitrogen. So nitrogen has only one lone pair of electron, and we know that nitrogen is less electronegative than oxygen. So here we have two lone pair of electrons on oxygen and it is more electronegative than nitrogen. Here we have one lone pair of electrons on nitrogen and it is less electronegative than oxygen. So what happens to the properties due to hydrogen bonding? Water has higher melting point. Ammonia has lower melting point. Water has higher boiling point, higher density, higher viscosity. Whereas liquid ammonia has lower boiling point, density, viscosity, dielectric constant and electric conductivity. But water has all these components higher, mainly because it bonds well. It has greater number of hydrogen bonds. This is the first property. Liquid range. Due to strong hydrogen bonding, freezing point and boiling point of water are higher than those of liquid ammonia. Okay, because of hydrogen bonding, both these points, that is boiling and freezing points, are higher than liquid ammonia. It is usually from 0 to 100 degrees. But here the hydrogen bonding is weaker. So freezing point and boiling point in liquid ammonia are lower than those of water. How much is it? It is minus 77.7 to minus 33.4 degrees centigrade. Approximately it is 44 degrees centigrade. What happens to the dielectric constant? Dielectric constant of water is 81 at 18 degrees centigrade, whereas for liquid ammonia is 22 at minus 33.4 degrees centigrade. So ammonia in comparison to water is a poor solvent for ionic substances because the dielectric constant is lower. Dielectric constant should be higher for ionic compounds to dissolve in that particular solvent. Viscosity. Water is more viscous compared to liquid ammonia. Viscosity is 0.959 at 25 degrees, whereas here it is only 0.254 at minus 33.4 degrees. Hence, what happens? Liquid ammonia provides less resistance towards the mobility of ions. Check here. It may not dissolve ions, but it makes the ions more mobile. Here, the viscosity is higher, so it is going to give resistance to the movement of ions. But here it is easily movable. So ions of soluble salts have greater ionic mobility in liquid ammonia than in water. Final aspect, Self-ionization. Self-ionization means the molecule ionizes on itself. You have water. Water self-ionizes to produce H3O plus OH minus. So the ionization constant is 1 into 10 to the power of minus 14 at 25 degrees centigrade. It's very important, right? When we study pH and all, we take the scale as 10 to the power of minus 14. Okay, 14 scale. Next we have ammonia. Ammonia self-ionizes to produce ammonium ion and amide anion, and K value is 1 into 10 to the power of minus 33 at minus 40 degrees centigrade. So what does this indicate? The extent of self-ionization in ammonia is much less than in water. It shows that ammonia conducts current to a very limited extent and is a better solvent for covalent substances. So these are the comparative accounts of water and liquid ammonia as solvents. Yeah, both of them are good for ionic compounds, but water is better than ammonia. Whereas for covalent compounds, ammonia is a better solvent compared to that of water because of these various aspects which we have discussed. We have so far discussed hydrogen bonding, liquid range, dielectric constant, viscosity, and self-ionization. Okay, so we have completed comparative account of water and liquid ammonia as solvents. So these are the references, and I hope you have understood this session. We will meet in our next session. Thank you.